Hello students, welcome back. Now let's go to section 4, elementary differentiation rules. Differentiation, what is it? Differentiation is a process to find out the derivative function. Alright, now our focus is finding derivative function, not derivative value, but derivative function. The first rule is rather trivial. Constant rule, addition rule, and coefficient rule. The derivative of constant function is always 0, and the derivative of sum is sum of the derivative, and derivative of coefficient times something, I can take the coefficient out. I'm not going to talk about the proof of the second and third rules because they can be a little bit rough. We'll just accept those. Now, as for the first rule, I can show you. You see, the average rate of change is always 0 because the numerator is always 0. Rise over run, but there's no rise because this is a constant function. As for the addition rule, yes, it is possible to prove, and so for the coefficient rule, but I'm not going to go there. How do we actually use? Well, we are not ready yet, so please be patient. The next rule will allow us to use all kind of derivative rules and do some computation. The power rule. Derivative of x to the nth power is n x to the n minus first power. So basically, the power comes out as coefficient and subtract 1 from the power. Now, if I combine this rule and all those rules over there, then we can do some derivative problems like these. Okay, here's a nice problem. Let's find out the derivative function. Ready? Okay, what is the derivative of x cubed? Well, we have this. 3x to the second power. Is that clear? I just use the power rule. 3 comes out front and subtract 1 from the power. That's a derivative. Next, we go to this derivative. 2 comes out and subtract 1 from the power. So what do you have? 6x to the first power, but nobody writes like this, right? Just nothing there, then 1 power is hidden. Now, 4x, well, this is 4x to the first power is hidden. So apply this power rule and multiply by 1, so we have 4x to the 0 power, but of course nobody writes like this. 0 power is just 1, so that's it. And let's go back to the original here. And finally this. That's constant, isn't it? Derivative of constant. So that goes away. But again, nobody writes like this. Just remove it, and that's the answer. So let's go back to this. We use power rule to each term. And we use the addition rule so that we can take the derivative term by term and add up. And also, we use coefficient rule, here especially. And then, if you want to find out the derivative evaluated at x equals, say, -2, then all I have to do is plug in x equals to -2 there. And what is this? 12 minus 12 plus 4, and that's just 4. Did I do this right? Yeah, I think so. And then, of course, I could have found out any other derivative value as well. Just plug in x equals to 1 and do your simplification. Plug in x equals to -1/2 and do your simplification. You can do all kind of things once you have the derivative function. So if you're looking for the instantaneous rate of change at a certain x value, the best way to do that is to find out the derivative function and plug in appropriate x value. Because plugging in the value is often a tedious thing to do, many times problems just stop here. Find the derivative function. Okay, we went through one problem. That was easy. Now we have a bit more challenging problem. How do we take care of this derivative? I don't see any square root expression from any of those derivative rules, do I? Yes, no? Yes, I do. I do see it. This is actually a power function. 3x to the 1/2 power. And I can apply the power rule here. How about the next one here? 4 over square root of x. As a matter of fact, this is, again, a power function. 4x to the negative 1/2 power. And then 2x square root of x. Looks like it's a product of these two functions, but no, actually this is a power function. X to the what power? 1 power plus another 1 power. 1 power times another 1/2 power, excuse me. So 3/2 power. Note that I didn't take any derivative. What did I do? I just changed everything into power form. It's just a preparation, okay? Do not mix up the preparation and the derivative computation. This is g of x I calculated. And then g prime of x, the derivative. Now let's apply the power rule. Power comes out, its coefficient. So what is it? 2 times 1/2? Just 1. And subtract 1 from the power. That's what I get. Is that clear? So this form, this expression, became this blue. Alright, next. Power comes out, and then subtract 1 from the power. So multiply 4 times negative 1/2. So this is actually negative 2 x to the, subtracting 1 from the power, negative 3/2, right? Did I do this right? So this one, this expression here, same as this. Excuse me, not the same, that's a derivative. Derivative of the red part. Now, okay, this one. Let's take the derivative. So multiply by the power, 3/2 times 2, so that's 3. And then subtracting 1 from the power, I get what? 1/2 power. So this thing, green part, corresponds to this green. By the way, here are the answer keys. So compare what I did with what's written here. As a matter of fact, excuse me, I made a typo here, and that created a bit of a mistake. Sorry about that. Oh. Okay. Let's come back and correct all these. It's a good thing I went back and opened the answer key, because I made a stupid mistake there. There was 3, and previously I wrote 2 there. A typo, and because of the typo, I made a mistake that coming afterward. Sorry about that. Let's go back here. It's 3, so 3x to the 1/2 power, and apply the power rule. 1/2 times 3 is 3/2. So that's the coefficient, and subtracting 1 from the power, we get negative 1/2 power. And then this is the same, 4x to the negative 1/2 power. You see, denominator means negative power, and square root is 1/2 power. So multiply and then subtract 1 from the power. Same here, multiply and subtract 1 from the power. So we went through 2 problems here, and one was straightforward because we had only integer powers. But the second one was far more complicated because we had radicals. Consequently, we had to deal with rational powers. Also, we had denominator, which means negative powers. Still, everything revolved around the power rule. let's stop here. We're going to talk about exponential and logarithmic functions in a separate video. And then as for derivative computations, well, there are many more derivative problems in homeworks, so I'm not too much worried. Go ahead, take your time, and you're going to find yourself getting familiar with these